just got a couple of quick new tool purchases. I went to my used tool guy and he had some good stuff, so I picked it up. And a couple of these we're going to be using in this video here. And first thing I got is these pomegranate vices here. This little guy. And here's a bigger one. And they're in really good shape. The only thing is it looks like somebody had these jaws closed and left them closed for a long time, so there's some rust on these jaw faces, but it's easily cleanable. I don't even think I need to use any kind of steel wool or abrasive or anything like that. I could probably use something along the lines of like Brasso or a metal cleaner, and that'll get that right off. You get them for a really good price, so we picked those up. Also, we had, I went a little bit shopping and picked all these up, and these little ones here, I think up until this size actually here, these were 50 cents a piece, and these are all 135-degree split points. And these bigger guys were $1 a piece, and the only ones that were used was this one here and this one. No, yeah, were these two. These two are the only ones that were used, and they're still in pretty good shape, perfectly serviceable. Nothing wrong with the cutting edge on this. Like I said, 135-degree split point. So all in all, a good buy with those. The other thing I got was these dividers here, and these are Lowentrout. And says there's a number 7 stamped in here. Now I actually looked these up, and these are super old. This company was around turn of the century, last century, late 1800s to very early 1900s. I think they went out of business in the late teens, early to mid 20s. So these are somewhere around that time. Very old, but still in pretty good shape for their age. Few dings here and there, but nothing big. The points are very nice and pointy. They don't even look like they're resharpening. They're perfectly level. So I picked these up, and I think it's cost me actually $2. And it has a nice locking tab here. And the last thing I got was this here, and this is a Mitutoyo. 505, 705, and these are made in Japan, and they are 8-inch calipers, but a little bit different than your normal caliper, where I needed a pair of 8-inch calipers because I didn't have one, and you can see they have a digit readout here. So as you open this, you can see the digit readout. Let me zoom in on here so you can see. Whoop. You can see the digit readout. Click over. I've never seen one like this before, and this reads in hundredths of an inch. So you read your hundredths of an inch off of this, and your thousandths off of this. So that's 3 inches, 193. I'm looking at this upside down. It is 93, right? Yeah, 93. So a little bit different, a little bit weird. Not necessarily necessary, because you have the numbers in the bar down here, but if you can't read those or those wear off, you got this little digit right here. So like I said, these are these go up to 8-inch, and I didn't have a set of 8-inch calipers. So I picked these up. Alright, so actually let's get on to the project for today. We're going to go over to the table saw and show you what the project is. Okay, so what we have going on with this table saw is this pulley is a little out of whack, and basically it's loose on the bore is loose on the shaft, so it's got a little bit of a wobble in it, which you might be able to see there. And it's not ridiculously affecting the way the saw works, but it is giving it some vibration that I don't like. And look about, it looks like a 5/8 shaft with the 3/16 keyway, and this pulley looks somewhere around, I don't know, somewhere between 2 and 3 inches. I haven't taken exact measurements of it. And just to show you what this is causing, let me start it up, and you'll see the vibration I'm talking about. So you can see it vibrating, and I can feel it in the saw, and you can see it right there when it slows down. It's not a whole lot of vibration in there, but it's enough to feel it in the saw. And you can see the wobble there. That vibrating that you heard was actually just this hardboard here. I have a piece of hardboard that I cut out. Let me zoom you out a little bit. Oop. Piece of hardboard here that I cut out to kind of contain most of the sawdust, so I could put a vacuum port on the bottom. So basically the problem with this is that it's loose. The bore is loose on the actual shaft, and when you tighten it up, it cocks it to one side. So you can see that there. Let me zoom in again. You can see the play in there. So we just need to get that a little tighter. So there are two ways you can go about this. This is just a cast aluminum pulley. Easiest way would be to just bore out this outside to the edge of that, to slightly beyond that keyway there, and put a bushing in, remachine the bushing to be a nice tight fit on this shaft here. And then the other way is to just make a whole new pulley. So we're actually going to do both. The new pulley is just going to be made out of aluminum also, because I don't have a piece of steel that's big enough of diameter. The largest piece I have laying around here I think is a inch and a half, inch and 3/4. So what we'll do is we'll use a piece of 3-inch aluminum, and we'll 6061, and we'll machine a new pulley out of it. And we'll also fix this one by boring it out and kind of putting in a bushing. Now there is a little bit of a problem with this, and you can see the way it's cast. The set screw has its own little protrusion here, and the keyway there that you see ends up right in line with the edge of that little protrusion. So we have to, what I'm probably going to end up having to do is come up to the next nominal size. So if this is 5/8, we're not going to be able to take an 1/8 inch out of it, maybe a 1/16 of an inch or so, enough to clean it up, and we'll get a piece of metal in there, and we'll Loctite it in, and we're going to have to leave a gap there, and I'll recut the keyway to meet it, which means that we're going to end up splitting that bushing. Not the greatest thing in the world, but with this pulley, it's the only choice I have because of this. I don't know, if I machine that all the way out to the end of the keyway, I'm going to have no bore there left. So plus this is going to be a little bit, I mean, I can grab it in the lathe fine. The only thing is this is, like I said, just cast aluminum, so I have to make sure that I don't squish this. Alright, so we decided not to even mess with the old pulley because I don't have enough room to put a bushing in there because of that little boss with the set screw. So it's not even worth the time. I tried setting it up on the 4-jaw chuck, and it was just all over the place. So we're going to forgo that completely because I see nothing but disaster, and we're going to make our own. Of course, you can go out and buy one, probably for maybe like $5, but where's the fun in that? So we're going to cut ourselves off a chunk. The width of our pulley, the whole width, including the hub in the front, will be 2.5 inches. I'm sorry. It'll be just slightly over 1 inch. And so I have here a piece of 2.5 inches that'll give me enough to chuck up here and turn down my V, and then we'll flip it around, and then we'll turn the boss. So let's get this cut to length. And now this saw, I haven't adjusted this since I moved, and this definitely got bounced around when I had it in the back of my pickup. So I don't know how straight this is cutting. I'm not going to bother adjusting it right now, because it's a whole nother project in itself. So we're just going to let this go. go. Okay, I got the 4-jaw set up here. I got the stock loosely in the chuck here. And what we're going to do is we're going to turn down a diameter of 1.5 inches by a length of 1/2 inch, roughly 1/2 inch. You know, it doesn't have to be perfect here. This isn't really critical. And that's just going to be the boss that holds the set screw. Then what we're going to do is we're going to take it, we're going to flip this around and hold it by that boss that we just made, and we'll be able to machine the outside diameter and the V, and then take off whatever other stock that we needed. So we're going to end up with roughly maybe about 1.25 inches or so here, length, maybe a little bit less, and I have this at 1.5 inches. I just gave myself a little bit extra in case the saw blade cut really crooked, and it actually did cut pretty crooked, but it cut crooked in the opposite direction. So we're actually added this side here is 1/2 inch, this side's a little over 1/2 inch. So I definitely have to adjust that saw, but let's get this all dialed in. Oh, and by the way, I'm gonna use the tool that James had given me, and we're going to try this out on this lathe. I still haven't put the adjustment screw back in here, so I just I put it up to the tailstock there and set center height, and you know, we're just not going to move it from there. Okay, so we got our indicator set up here, and hopefully you can kind of see that if I do this a little bit. Alright, so we're just going to spin it here, and obviously we're off. Let me actually see if I can get that more straight on. It's not ridiculously critical, but the straighter you can get it, the better. So we're going to find our low spot, which is right there. I'm going to set a 0 on our low spot. I'm going to go here, and I'm going to say what? Our high spot is 78. So half of 78, half of 70 is 35, half of 8 is 4, so 39. So we're going to go to 39, we're going to set 0, and we're going to go to our next closest jaw, which will be this one, and we're going to bring that to 0. This is the one benefit of being able to reach around the chuck here. And we're going to the next jaw, and we're going to bring that to 0. Alright, so now, just by doing that, we should be pretty damn close. So we're pretty much within a thou, which is more than what we need. Actually, we're within about a half. Just by doing that, we're within a half. Let me zoom you into that dial, just so you know I'm not BSing you there. There you go. Simple, quick, and easy way to indicate a 4-jaw chuck if you have one that's small enough that you can reach around. Alright, so what we're going to do, again, we'll face this off, and then we'll start making our little hub for our set screw. Hey, Alex, good there? That's a mirror smooth finish, but we're definitely going to kick up the feed rate here. We'll do, we'll say 8,000 per revolution. And I gotta change out my tool because it's getting stringy and crazy, so I'm gonna start just touch there. You know, again, this isn't ridiculously critical. So we'll touch, and then we'll set our indicator here. Get it at 0. The 200,000 is cut. So we're going to drill this and put the hole in it now. I have that 1.5 by 1/2 inch boss hole set. We're all cleaned up. Let me center this a little more. There we go. And I actually I measured the shaft, and we are 0.6 to 3.5 or so. So it's slightly under 5/8, and I have a 1/1000 under reamer. So actually this is what we're going to use. So this is 0.624, and this is what we're going to use. So we're going to drill this out, we're going to ream it, and if I have to massage it or anything after the fact, we can use a little flap wheel and just take off a little bit until we fit the shaft very, very nicely and very tight. So we have a reamer to do that. So I'm gonna step drill this, and I like to step drill it because this lathe doesn't particularly like busting through with one big drill bit. So I'm actually gonna just step it up into three drill bits, and it'll make it go faster. Once I get the center hole in there, then the other 2 drill bits to open that up to the correct size will blow right through there. Again, if this was a more stout machine, you'd be able to go at it a little bit faster, but you know. You get to learn the quirks of your machine, and I do know that this machine doesn't particularly like me doing that. So we're gonna have to step drill this, which is not a big thing. So let's get some cutting lube here. And I'm using those new drill bits that I picked up. nice clean reamed hole. Let me grab a chamfer tool here. There we go. There we go, a nice lead in into that. Okay, so this side is pretty much done except for putting the set screw hole on there, which obviously we'll do after the fact. So what we're going to do now is take this out, flip it around, and grab it by the piece that we just did. What we want to do is just face this flat, and then I can draw this out. I gotta, since it's that the flat of this is resting nice on these jaws, I can face this, and we know we're parallel with this face and this face. So then I can bump it out that extra little bit just to get the tool in behind here, and then we can indicate this face and indicate this face. Okay, so I'm going to get this out of here. And we're just going to loosen this real quick. I'm just going to draw it out just a hair, so that way I can get the cutting tool in behind there and make sure we clear the jaws. Maybe a little bit more on that. Oop. Somewhere in that neighborhood. We'll snug these down again. Now I have this face and this face are parallel to each other, so I can indicate this face to make sure we're not wonky. Low. There's high, so we're 12, so we're going to go 6. I'm going to set 0. Come up to the next set of jaws, and I'm going to bring those to 0. up to the next set, and same thing. Alright, that's pretty good. Now we can go to this outside face here. We're within a half. Come back here. And a half. And we're dead nuts. Okay. I don't know if you can see that there. Alright, so we're all dialed in. We got to bring this outside diameter down to 2.5, I'm pretty sure. Let me just double check. Yep, 2.5. So I'm going to bring the outside diameter down to 2.5. We'll just say it's not ridiculously critical, so we're just going to use calipers. We don't have to use the mic. So we got 2.5, and this is, I think, 2 5/8. 2, 6, 2, 5. Yeah, 2 5/8. So I got 125 to come off of here. Alright, so we should be pretty close. I think we should be about 5 or 6 off. And we are 4 off. So let's take the last 4. And there we go. Alright, so now I'm going to set up for the actual V-groove. And the way we're going to do that is we're going to make a relief in the middle so we have enough room for a tool to get in there. And we're going to cut this angle and then cut this angle. So what I'm going to do is get the old pulley and I'm going to measure the end of the V-groove, the bottom of it, as best I can. And we'll see how big of a groove we can get in there. Okay, by my calculations, about 330 thousandths should be the middle of the V groove. I'm going off measurements off the old one, so we're going to use this here to plunge in down to a 1/2 inch. So that's 1, 2, 3, 10, 20, 30. So the right hand edge of this prodding tool should be on center of the old pulley, which I can kind of double check here. And that looks pretty good. Just gonna make a light scratch. And we are gonna double check. Alright, that looks pretty much on center with that. Should be more in this direction here. Alright, that looks pretty good. So I'm going to slow it down and we're going to plunge into a depth of 1/2 inch. Okay, so what we're looking for is a 30-degree angle, 15 degrees per side. I know it's not 100% accurate, but that's what the other one was at, and that'll fit a belt. That's kind of a happy medium in between everything. So what we're going to do is just start dragging this down and cutting our angle in. Okay, so that looks pretty good. We got our angle all the way up. We're just a little bit thicker than the other one, but that's no big deal because I can move it up and down on the shaft no matter what. And what we'll do is we'll come down on this end here and we'll cut the other angle and we'll make it to fit the belt. So right now let me just chamfer this outside edge. There we go. I need a chamfer tool here, something I can see if I can. I'm not gonna be able to get in there with that. Now it looks like we'll just use a file. It'll be fine. So we're going to switch it around to 15 degrees the other way, and we'll start whittling this away until it meets the bottom there. Okay, so now we got to do this angle here, and I'm going to run the lathe backwards with the tool upside down. You just got to be very careful with the threaded chuck with this. Alright, that should be all I'm going to take here. Should be right there. Yeah, that's just even with the top. So now we'll just clean this up, break this edge. Okay, you can see there's the finish there. We'll get a better close-up look at this after. And I'm just going to cut the end of this off. I'll just face off maybe about 1/4 of an inch or so. Match this other edge here, which I'll do off camera, and then we can cut the keyway. Oh, we can, I want to cut the keyway first, or do I not want to cut the keyway first? I'll think about that. Okay, we just set up in the drill press to drill our hole for our set screw. I just want to show you how I squared this up, and we're actually using a new palm grain vise in here. It works really well. I got one of these little doohickeys here, which, as you can see, there's a little line on the top and a line on the bottom, so you get that squared up with your stock there, and you can see 2 lines line up. Then we know we're in center this way, and then I just used the tip of the center drill to make sure we're on our scribe line, and just took a little brass hammer and tapped the vise around until we got it nice and right where we want it, and then just pop the C-clamp on there and tighten it down. So now we're just going to take our little center drill here, and we're going to start our hole. You want to do that especially since it's on a round spot. You want something nice and stiff that'll give you a good starting point for your drill. Okay, I want to show you the setup we got. We got this tool block 90 degrees to the face here by putting a tool block here and running it up. We ground ourselves a tool bit here. That's the size of the key, so it's 3/16. And we got about a 8 to 10 degree lead angle on it that way. Okay. Now, for center height, I have a another boring bar here. Well, that's not it. What did I just do with it? I have this other boring bar here, which just happens to be 5/8 of an inch. So we put it in there, and I was able to get center height by lining up the 2 set screws and feeling around the edge and looking down it, and we got that's how we set our center height. Now we have to make sure that this tool is perfectly level. So I stuck a tool bit in the back here, and this lathe is level. So we took our little hand level and put it up against that tool bit there, rotated it around until we got our level, and we're there. Okay. Now this, you can see I stuck the tap in here, and we rotated the chuck. We did the same thing with our level until our bubble was in the middle, and then we locked our back gear, so now that can't move. So now all we're going to do is take this tool bit and basically work it in and out like a shaper and shave a slot into there. And I'll bring the camera around to a better angle here, and we'll see that happening. And I might have to extend the tool out a little bit to get my depth. You just have to make sure that, since this is a 1/4 inch hole and a 3/16 slot, we have to make sure that we're sitting on the bottom of that square hole. So when we get it out and to pull it out, we'll just have to make sure that we're level again and we're not cocked up on the side. Okay, so we're ready to put this on. So here's our finished pulley, all polished up here. And the only thing I have to do is get a smaller set screw. The one that came out of the other one, I don't know where the hell it went, actually. I put it somewhere safe and, you know, put it somewhere a little too safe because I can't find it. So this one works, but it's just a little too tall. So I'll get a shorter one. We cleaned up the key and made sure everything fit nice, polished up the shaft. You can see the key sticking out of the other end, so I'm just going to even it up at the end of the shaft. This should be pretty close to where we need to be. Alright, so that looks 1,000 times better than the old one there. Get something white under here just so you can see. Alright, I'm just going to turn it on real quick. Might just get a little bit of vibration out of the motor. That's just this wood vibrating in the motor bracket. As you can see, dead on true. That's just a motor bracket vibrating, nothing big. So loop this here on the pulley. Looks pretty good to me. Alright, we'll start her up and see where she goes. Let me zoom you out. Saw how much vibration we had before. Not much of anything. The only vibration in that is the actual belt. You run super smooth now. The only play I have is just a play in the shaft of the motor itself. You can see that little bit in the bearings. These actually aren't ball bearings. They're a cast iron sleeve with a wick around it for oil, just like the motor on the lathe. So you get a little bit of play in and out. But other than that, we're 1,000 times better. I don't feel the vibration nearly as much. We got a little bit of vibration, but you know, it's a table saw. It's going to vibrate a little bit, but we're not jumping all over the place like we were before. Okay, so now obviously this is a cast iron top. We're worried about rust prevention, things like that. Down here it's not so bad, so we don't have that much rust to contend with. I got a few spotches here and there that were there when I got this saw. But what we do care about is having a slick surface. So just, you can see I'm just flicking the wood and it's kind of sticky. And to get a nice smooth surface to run the wood along
and also to have a little bit of rust prevention. It's not going to prevent rust per se, but it'll give it a nice protective coat. Good old paste wax. This stuff works on everything. I also use this on vices. Works really good on those 2 new pomegranate vices that I bought. It works really great on those, and it obviously it doesn't leave a residue. Which is the biggest thing on something that's wood, is you don't want to use anything that's silicone based, otherwise it'll leave a stain on your wood which you won't be able to get off. So this won't, and it'll give a nice slick surface to the top. So all you do is, just like you wax in the car, is you know, take some of that, rub it on, and it will take some of the dirt off and some of the light surface rust. You can see the color change there. So just get this all waxed up, everything including the fence, the side of the fence. There are plenty of products to use on this that are probably better than this, but they're relatively expensive and you'd have to buy them online or at a specialty woodworker shop. This is available at any hardware store. Hell, you can even get it at grocery stores. Okay, so we're all buffed out. We're nice and smooth. Now this is subjective, but here's the same piece of wood we had on there before, and we're just going to give it roughly the same amount of flick that we did before. See how easy that moves across the bed. Also, here's the miter. Super slick. So now all the wood will slide nice and easy over this. You're not going to bind up, and you're not going to get that kind of stuttering as you push it. Makes for a smoother cut, easier operation, safer operation, because you're not forcing yourself into your work. And all around better machine. So we have a slick top, no vibration, project's done, and I'm happy with it.